Okay, lots of questions on exam 2, and we're going to go through them all. And I'm going to divide this up into 3 movies, so not to worry. We're going to start with question 11. And here we have mean mu equal to 910, and sigma is equal to 5. And we want the probability that x is greater than 900. That's a 9. So we're going to have the probability that z is greater than 900 minus 910 over 5. Okay? And that's going to be the probability that z is greater than minus 10 over 5, or the probability that z is greater than minus 2. So if you were going to draw a picture, there's 0, here's minus 2. That's everything to the right of minus 2. So when you look up minus 2 in your table, that's giving you this part, and you don't want that. You want everything to the right of that. So what you're going to need to do is take that value that you got out of the table and take 1 minus that. Okay? So, let's change slide. We're going to have 1 minus 0.0228, and that's going to give us 0.9772, which is as it should be. Okay? So that's everything to the right of minus 2, because it's talking about greater than. Good. All right, let's take a look at problem 16, and I think I know where your problem is going to be right off the bat. The mean mu is 10, the variance sigma squared is 4. They give you the variance, but they don't give you the standard deviation. However, that's an easy fix, because standard deviation is simply the square root of variance, and the square root of 4 is simply 2. So when I want to solve that problem, the probability that x is less than 12, I'm going to have the probability that z is less than 12 minus 10 over 2, and that's going to be the probability that z is less than 2 over 2, and that's going to be the probability that z is less than 1, and all you have to do is look that up in the table, and that's 0.8413. Okay? Not scary at all, is it? Not a bit. Okay? Good. Let's look at 17. Change slides. Now 17, if you remember the empirical rule, you're okay. The empirical rule gave you that thing about 95.44% are within plus or minus 2 standard deviations. But if you didn't happen to remember that, you can always do it by hand. Okay? And this is actually where the empirical rule comes from. If I have the probability that z is between minus 2 and positive 2, and I want to solve that, I take the probability that z is less than positive 2, subtract out the probability that z is less than negative 2. So I have, when I look up positive 2, I get 0.9772. When I look up negative 2, I get 0.0228. I do my subtraction. I get 0.9544, and this is in percentage terms, so that's simply 95.44. Beautiful, isn't it? Percent. Cool, huh? All right. Who's ready for problem 20? Yay, problem 20. Woo! Let's get a nice clean slide. So in problem 20, we have mu equal to 69 and sigma equal to 9. And this is the one about the grades, and we were looking for the top 5% of the grades. So let's draw our picture. And what we're going to do, let's see, here's 0. We're going to look at the standard normal first. There's our mean mu of 0, my crappy drawing. Okay, here's my top 5%. Here's 95%. And I'm looking for that horizontal value right there that cuts off the 95 from the 5. So what I'm going to do is look for the probability in the middle that's the closest to 95%. And that's that funny one. If you look, there's the 94.95 and the 95.05, and most of the time you use that 1.645. And if you use 1.64 or 1.65, you'll get a real close answer, so don't get choked up about that. Now, the formula that you're going to use is x equal to mu plus z, z referring to the horizontal value here, times sigma. So mu is the 69 plus, in this case, the 1.645 times the sigma, which is 9. And that's going to be 69 plus, where'd it go, 14.805. And then you're going to get 83.805, something like that. Okay? And that's going to be the cutoff for your top 5%. Pretty cool. All right, let's try one more on this movie and then we'll take a little rest. So on problem 21, we have mean mu of 2.25. We have sigma of 0.15. Now in this one, we're looking for the 77th percentile that contains a certain amount. So let's look at our picture again. And the shaded in part is our 0.77, our 77%. So down here, we actually have 23%, or 0.23. So we need to find this horizontal value here that cuts off the 23 from the 77. And the closest hit that we're going to find is 2296. Sorry about that. Let me clean that up a little bit. $22.96. That's the closest hit I found. And the value that's attached to that is minus 0.74. Okay? So when we plug into our formula, we're going to have 2.25 plus a negative 0.74 times 0.15. And that's going to give me 2.25 minus 0.111, or 2.139. And the closest answer that you have in your set is 2.14. Okay? Hope this helps.